Hello, welcome to a follow-up on my previous Perceptron coding challenge. So if you happen to watch the previous one, and if you hadn't, you probably should go back and watch it, link in the description. I created a simple perceptron. A perceptron is a model of a single neuron that receives inputs and then produces an output. And this is a very simple scenario where the output is only trying to guess whether a point is on one side of the line or the other. Is it above this line or below this line? So in this follow-up video, what I would like to do is really just refine this example, nothing really about the mechanics of the perceptron itself, but make this example a bit more sophisticated and allow for some more, possibly some more creative possibilities. So first thing, I got a bunch of things I'm going to do. I would list them all, but I can't remember what they are. So I'm just going to tell you what the first thing is. The first thing is, let me come over here to the whiteboard. So what I did with the first perceptron was just use the raw pixel coordinates of the processing window. I can't remember what size it was, but it was like a 640 by 480 window, and 0, 0 is over here. And this turned out to be the line, and I was looking for points over here. But the idea of using a neural network-based system is typically to get some kind of data input that's not based on pixels. So what I think that I want to do here is just redo this example and consider a Cartesian plane with 0, 0 in the center and y pointing up. So whereas this is 0 and this is 480 down here, 480 would be kind of up here. So I would like to just redo this whole example, and then the line y equal x we should see as appearing like this. The reason why I want to do this is the next thing that I'm going to do is create a perceptron that will learn any division of data points. So it doesn't just have to be a division that's slicing it right down the middle. So first let's make that change. Okay, so how do I make that change? Well, where do I make the points? I think I had this point object, and the point object makes a random point with a random x value and a random y value. What I'm going to do, and I think, I'm going to just make these now random values between -1 and 1. -1 and 1, okay? So the random values are between -1 and 1. In some ways, that's it, done, aha! But now, right before I show them, what I want to do is I'm going to say px for like pixel x, and I'm going to map x, which has a range between -1 and 1, to 0 and width. Map is a built-in function in processing that takes a value with one range and maps it to another. It's very simple math, and I actually have a whole other video, which I will try to link to, that goes over the map function. And y, I can do the same exact thing. So let's look at this. Except for with y, right? What I want is y. When the y value is high, I want it to be low in terms of, when it's high, I want it to be, it's flipped, right? 0, 0, instead of positive pointing down, it points up. So I want to reverse that mapping. And the map function does that for you by saying, hey, when y is -1, it should be at the bottom. And when y is 1, that's a nicer way to say it, it should be at the top, 0. Okay, now what happens if I were just to run this? It kind of looks like a whole lot of nonsense, right? Didn't seem to work. Well, first of all, I forgot a major thing. I did the mapping, but I'm still drawing the ellipse at those values. So I'm going to say px, py. Okay, good. Look at this. There are all the points. And you can see how they're divided, but the line is drawn in the wrong place. So where do I draw that line? So I'm just going to change the coordinates. I'm going to hard code new coordinates for the line. We'll deal with that later. But so I'm going to say 0, comma height to width, comma 0. And we should see, there we go. There are all the points. Now, what's going on? Before I had this thing in this program where I would draw a red or green ellipse whether or not the perceptron had guessed correctly. And that's not working anymore because I am not doing the mapping anymore. So I need to also just take this same exact math, and probably I should package that into a function or make it part. Oh, you know what I should do? I should make, the point object should just have a function that's called get pixel x. It's a little bit of an awkward naming, get pixel y. Let's just call it, forget about pixel x and pixel y. So I'm just going to calculate these on the fly whenever I need them. And pixel x will do this, return that mapping, and pixel y will return that other mapping. There we go. And then I can just get those values here and get those values here. This should be the same, but at least I took that mapping and put it into its separate function. That way when I need it here, I can say t.pixelx and point.pixelY. So rather than draw the ellipse at that points x and y, I can trigger those pixel x and pixel y functions. Ooh, I like that. That was a nice little addition I had there. This is exactly the same program. The only thing that's different is the points now live in a sort of traditional Cartesian plane, and then I'm mapping those points into the pixel space when I want to draw them. Great, so that's step one of this follow-up video complete. Let's do step two. So what is step two? I want to change, what I want to change here is this. If x is greater than y, I want to be able to have, let's come over here, any particular function. So I could say y equals 3x plus, plus 2, right? That would mean if x is 0, then if x is 0, then y is going to be at 2. If x is 1, y is going to be at 5. So you can see this is that particular line. So I want to be able to train the perceptron to recognize this versus this. And I want to be able to change this formula. I can make it negative 2x minus 3.7. I want to be able to have any generic formula for a line work with this example. So let's add that into the code. So I think the easiest thing for me to do, and I'm just going to put it in this tab, is to write a function. I'm going to call it, it's going to return a float, and I'm actually just going to call it f. Is that like a terrible thing to do? F of x being the function for, maybe I'll call this like line, whatever. I'm going to call it f of x. And I'm going to say return, what did I say? 3 times x plus 2. So this function basically represents the formula for the line. And I'm going to say y equals mx plus b, right? That's the formula for a line. We've seen this in other, so funny how all these examples have this like two-dimensional space with a line in it, because this is the simplest way to start working with data and visualizing that data. But ultimately, as I get further along in these machine learning examples, we're going to have these n-dimensional spaces that we can't even fathom or visualize. Okay. So now the one thing that's a little bit of an issue with this is my mapping is between -1 and 1 and -1 and 1. I want to make sure the line isn't kind of off and out of our view. So what I'm actually going to do is I'm going to have this be 0.3 times x plus 0.8. Again, I could have changed the mapping to between -10 and 10, but I kind of like this idea of between -1 and 1 for whatever reason. So I'm going to change it to that. And now what I'm going to do, I at least just want to draw that line. So I'm actually not going to change any of the code in this example. I'm just going to see, can I draw that line? So this is where I previously drew the line. So what I want to do is I want to draw a line from where? I want to get the y value for when x is -1 and the y value for when x is 1. And then I can draw a line between those 2 points. So, okay, so I'm going to say -1, f, so I'm just going to say x equals -1, y equals f of x. And this is x1, y1. And then the second point is x equals +1 and y equals f of x2, y2 is f of x2. So I'm going to draw a line from x1, y1 to x2, y2. And this is perhaps a very long-winded way of writing this, but just to see, what I'm using is that formula for a line to get the corresponding y to a certain x. Okay, let me run this. What's wrong with this function? Oh, whoops, I have to say float x. I lived in JavaScript land for a second. I must set the type for that variable. Probably everybody in the chat was probably shouting at me about that. Okay, where's the line? I don't see it. Why don't I see that line? Ah, guess what? Guess what I forgot? I have to do that mapping. All right, everybody, settle down. I'm gonna do it. I'm gonna reuse that pixel y. So I'm gonna say point P1 equals a new point, which is at -1 f of -1. I'm gonna write this in a bit of a crazy way. P2 is a new point. New point between at 1 f of 1. Okay, and then I'm going to draw the line from P1 pixel x. Can I please type today? P1 pixel x, fast forward this part, I'm typing here. P1 pixel y, and then P2 pixel x, P2 pixel y. But look at this. Why am I getting an error here? I want to make a point at a specific x and y. What does point do? What does the point object do? I can make a point at a random point, but I can't seem to make one at a specific point. Well, guess what? Guess what? In Java, processing is Java, you can do something called overloading. It just so happens that I'm going to cover overloading, constructor overloading in this case. I can say I want to have another way of creating a point. And I'm going to use the underscore, kind of ugly underscore notation. But what I want to do is have some arguments to the constructor. I don't want to call them x, y, because the point objects variables are to x and y. So I'll call them x underscore. And that's going to be a way that I can do this. I could also figure out the label, but I'm not going to worry about the label in this case because I'm not labeling these points. I'm using them just to draw the line. Okay, so now that went away and I should be able to, there's that line. So there's the line. Boy, this was a lot of work just to draw that one line. And you can see though, I can change the formula for the line if I say, minus -0.2, now the line is further down. If I say minus 0.3, now the line is pointing the other direction. So I can now create any formula for the line and visualize that in the window. Okay, so now, what's going on here? So now that I have this formula for the line, I need to change this. No longer do I want to check just is x greater than y. How do I determine, and I'm looking for my eraser, how do I determine whether a given point is above or below a line? So let's say I have this line, and the line is y equals 3x plus 2. I know it should be, all right, let me try to be more accurate about this. I'm going to point it up more. And I have some point, so let's say I have the, this is the Cartesian plane here. Oh, I'm kind of drawing this as a mess. Okay, so let's say I have the point x, x comma, x is 3. So if x is 3, then this point is 3 comma 11, right? I think because 3 times 3 is 9 plus 2 is 11. So if I had the point 3, 12, it's above if the y is greater than the y that would be on the line. And if I have the point like 3 comma 3, it's below if the y is less than the y that would be on the line. So I can do that for any value of x. So if I take any value of x, all I need to do is calculate the point that's on the line and see whether it's greater than or less than. So let's add that into the code. So here what I want to do is I want to say, I'm going to say line y equals f of x, right? I'm going to calculate the actual y value for this particular x on the line. Then all I need to do is ask, is the y value above it? Then it's a 1. Or is it below it? Then it's a -1. So hey, that was easy. That's done now. And there we go. So we should be able to see this perceptron over time learning to figure out whether points are above or below that line. It's a little bit stuck right now. You can see that it's, and this probably has to do with learning rate and how it started, how the initial weights were started. But so I want to kind of figure out like why is it kind of stuck? So why is this here's the reason why this is getting stuck. And I mentioned it in the previous coding challenge and I completely forgot about it until now, the bias. So let's talk about why does there need to be a bias? Here's the thing. Let's consider the point 0, 0. When I say, this is the point 0, 0, y equals 0 times x plus 2, the corresponding y value is 2. So 0 is below the line. Here's the thing, with my perceptron, as I send in the x value and the y value, if I send in 0, 0, no matter what these weights are, if I multiply the inputs by the weights and sum them, I'm always going to get a 0 coming out, which can't be right. And this actually, in this formula for a line, y equals mx plus b, these weights are actually describing the rise and the run. Those are the right terms of the line. The slope, the numerator and the denominator. You can almost think of this as, I think, weight 1 divided by weight 2 times x plus b for bias. The bias being the y-intercept of that line. Where is it? So what the bias is in a perceptron is another input that always has the value of 1, but has its own weight. You can call it the bias weight. And now you can think of this formula as y equals weight for y divided by weight for x. Or is it the other way around? Somebody's going to tell me in the chat. Times x plus weight for the bias times 1. So hard, this is sort of times x. Does this make sense? So this is really what the perceptron is learning. We know the formula for the line, and we could do all this with maths. A neural network is often referred to as a universal function approximator. Thank you to the chat who just posted that terminology, right? With a simple like two-dimensional space and a formula for a line, we can do the math directly. But here, you can imagine once our data inputs once we have all this data with lots and lots of inputs beyond that are in n-dimensional space, we want to be able to approximate a function to work with that data. And we're seeing this beginnings of that here. Okay, so let's go now and implement the bias in the code. All right, so for the bias, there's a couple things I want to do. Number one is I'm just going to add that to the point. I'm going to say it has float b for bias. Let's just call it bias. And bias is always equal to 1. So every point is going to have an x and y and a bias. And then the perceptron now needs to have 3 weights. Needs to have the weights for the 2 inputs, the x and y and the bias. And one thing I might do is give the perceptron constructor a number of arguments so that we can have a sort of more generic perceptron, and I can say weights equals new float n. And then when I create the perceptron, I want to say perceptron 3. And then here, this was just something I had just to test the code. Now the inputs should always be an array of 3 things. And is there another here, training? I should always make sure to include that bias. I think I was able to get all of and so let's run this again. We can see that it's still a little bit stuck. I'm pretty sure that I have the correct code now. But here's a way that I'm going to be able to determine whether it's working or not. What I want to do now is also visualize what the perceptron currently thinks is the line. So remember, this is where I drew the actual line, the correct formula for the line. What I want to do now is, I think I could do this with the perceptron. So I can say point P1 equals new point -1, and I'm going to say, what did I call the perceptron? Brain dot guess y, -1. So I'm going to ask and P2 is 1, brain dot guess y, and then I'm going to draw the line, let's call this P3 and P4. So I am going to attempt to draw the version of the line that the perceptron thinks, and this should be 1. So now if I go into the perceptron, and I say, I already have a function called guess. Guess y. It's a little bit awkward here naming-wise. Guess y. And I have an x value. The formula for the line, so the slope should be weights index 0 divided by weights index 1. And the y-intercept should be weights index 2. So I should return m times x plus b. So something's happening here, but I think I'm off, right? Maybe what I meant to say was weights 1 divided by weights 0. So this is the line trying to learn. Boy, it's really not doing a very good job. So I think I need to take a closer look at this and figure out if this is really right. I was just kind of trying to guess. So there's a way we can actually do the math for that properly. Remember the perceptron, right? The x is multiplied by a weight, the y is multiplied by a weight, the bias is multiplied by a weight. All those are summed. So the formula for the line that it's learning is actually the 0 weight times x plus weight index 1 times y plus weight index 2 times b. All of this should equal 0. So that means weight index 1 times y should be weight index 2 times b minus weight index 0 times x. And then y should equal weight 2 divided by weight 1 times b minus weight 0 divided by weight 1 times x. I think that's right. That's pretty different than what I have. Let's take a look. Oh, there's a major error here. Even before I got to this, thank you to Ethan Elliott in the chat, I forgot to initialize the bias in this constructor. What a disaster. So probably do save me from myself. I'm just going to initialize it up there. Wonder, that's really gonna, so I never actually even had a bias. So I think this is actually working, but I'm not visualizing this line perhaps correctly. So let's go back now and let's see, where do I want to do that? I'm going to say y equals, so let me use the formula that I just used. Return, so let me do this. I'm just going to create some shorter variable names to make this easier to look at. And I'm going to say return, I'm looking over here at that formula I wrote over here. I'm going to say return W2 divided by W1 times B times bias. Oh, times 1. The bias is always 1. So W2 divided by 1 plus W0 divided by W1 times that x value. Now let's take a look and see now if things are working as they perhaps should. I think you can see that it's actually, I flipped somewhere. Am I missing a negative? Oh, this should be negative. Switched this to negative. This looks very close, but it's kind of off, right? Thank you to the chat. Somebody in the chat just told me that my equations are wrong, and they are. This should be negative, right? Because all of these add up to 0, so I need to take, to make this equivalent, y1 times y equals negative y, w1 times y equals negative w2 minus negative w0x. Oh, that's going to fix it. Okay, so now I'm going to say negative here, and we're going to run this and we're going to watch the perceptron over time, and you can see as it's correcting, all those circles are turning green. With this learning rate, slowly over time, the line is converging to the correct spot. Ta-da! Perceptron learn the line. So, you know what, there's going to be a part 3 and a part 4 to this because I think I'm going to wrap up this particular video. There were some other things that I wanted to add to this, but at least now in this video, I've added the bias. I've made it so that I have a Cartesian space I can work with, and I can work with any formula for a line. As you can see, life is just one big refactoring, and there's so many things I could do to refactor this. And visually, I still don't necessarily love what I have here in terms of explaining what's going on. But at least now, let's just, before I go, let's make a new formula. Shout out your numbers to me. Nobody can shout out to me. 8, 9 times x plus 0.2. Or let's do minus 0.2, minus 0.1. Let's just have a different formula for a line and see that this, again, works. We can also probably have a much better sense of what learning rate is doing. Like, look what happens if I make the learning rate 0.2 right now. You can see how it makes these very large movements. So it gets to the correct answer very quickly, but it can't do the fine detail to really find the correct spot. And if I make the learning rate really ridiculously small, you know, you can't even see. I mean, it is, in theory, this line is moving. It's so small that I can't even see it. Let's not be so crazy. Let's do that. I can't even find the line. The line currently isn't even in the space, because remember, it starts with something random. Let's run this again. So this line is moving, but it's just really, really, really slow. So it's all about finding, and that learning rate can change over time. I could start with a large learning rate. I should make a slider to adjust the learning rate. I could start with a large learning rate so it gets close. Look at that, it just locked right in. And then I could lower the learning rate for those refined movements. Okay, so I have a couple things I want to do. I think I'm going to make a couple follow-up videos on this. They'll appear at some point. But there was a great comment in the original first version of the coding challenge about adding data that is not part of the training set, which of course is very important in machine learning. So I'm going to do that in the next follow-up to this Perceptron coding challenge. Thanks for continuing to watch.